أعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. اقرأ باسم ربك الذي خلق، خلق الإنسان من علق. اقرأ وربك الأكرم الذي علم بالقلم، علم الإنسان ما لم يعلم. كلا إن الإنسان ليطغى أن رآه استغنى إن إلى ربك الرجعى.
Jazakallah. The Institution of Mechanical Engineers (IMechE) is an independent professional organization that represents mechanical engineers and the engineering professions worldwide. IMechE was founded in 1847 and is headquartered in London, UK. The institution has over 120,000 members in 140 countries. 𝐈𝐿𝐴 UET Texla student chapter is the first student chapter of 𝐈𝐿𝐴 UK in any public sector. It is leading technical society of the university, focusing on professional and grooming and imparting true technical skills to undergraduates. Solidworks Bootcamp is a training program designed to provide hands-on experience and practical knowledge of SolidWorks, a popular 3D modeling software used in various engineering and design applications. The objective of the SolidWorks Bootcamp is to provide participants with the necessary skills and expertise to create complex designs and assemblies, as well as to prepare them for SolidWorks certification exam. The purpose of SolidWorks Bootcamp is to provide participants with a comprehensive overview of SolidWorks software, its features and tools, and how to use them effectively in real-world applications. The SolidWorks Bootcamp also aims to enhance the problem-solving and critical thinking of participants, as well as their ability to work in team and communicate effectively. As you all know that our previous session was about surfacing and today's session is about sheet metal and weldments. Let me introduce you to our speaker of today's session, Mr. Ammad Ejaz. Mr. Ammad Ejaz is talented mechanical and industrial design engineer and top-rated freelancer with over 4 years of experience in CAD design. He is a SolidWorks expert who has achieved 2 certificates and has been recognized by Dassault Systems for his excellent work. Before handing over the stage to our speakers, following are some instructions you need to follow. Participants can turn their cameras on as per their convenience. Please have your laptops ready. Should be sitting in a quiet and proper place. The procedure for asking questions will be by raising your hand or by asking in the WhatsApp group. So for further insights, I'll be handing over the stage to Mr. Ammad Ejaz. Let's give him a warm welcome. Over to you, sir.
Assalamu alaikum, ladies and gentlemen. This is your speaker of the day, Ammad Ejaz. In this session, we will learn about sheet metal and weldments. So far, you have learned about the basic methodologies for designing any component. But these methodologies were just only for designing of the component and designing for assembly purposes. In this session, we will be learning how to design a component for its actual manufacturing purposes. So far, you have designed the component and assembled them, and you have learned how to make parts to give an attractive look for the visualization purposes. So first of all, let's go to the SolidWorks. Just like any other operation, when you open SolidWorks, you will go to the part assembly and drawing features. Today, I'm using SolidWorks 2021 feature, 2021 version. So you might see some changes in the way. To start any operation for the sheet metal or weldment, just go to the new file and start a part file. Okay. On the top bar, you can see we have used features, sketches, and other features. So to enable sheet metal, just right click on this bar and go to the tabs and hit sheet metal. Now you can see we have sheet metal over here. In the next step, we will be using Weldment for this purpose, and same you can go into the tabs and hit Weldments. So what is sheet metal? Sheet metal is like providing a surface plane and cutting it for the bending purposes. Like if you want to make a box of metal, what we will do? We will not make it by casting. We will make it by using sheet metal. Like if you want to make it with the thin film, like you want to give it some thickness. For this purpose, you can use sheet metal. In actual applications, most of the industries are not producing any component by using casting. Casting is also a manufacturing process, but most of the industries are using sheet metal for these purposes. In this method, uh, we just made up a profile and cut it into the appropriate positions. And a laser cutting machine will use DXF file and cut the appropriate lengths. And then after cutting it into the proper dimensions, we will use bending operation and then welding operation. So there are two methods for the sheet metal operations. First of all, you can convert any component into sheet metal component, or you can define another component, a new component, as a sheet metal component. For this operation, just go to base plan tab. This base plan tab is just like a base box extrude feature. For this operation, just go to the box plane tab. It's asking for a plane. Just like any plane, I'm gonna go with top plane. Select the top plane and define a geometry. Let's say I'm going with a rectangle tool. Define its dimensions. Currently, we are working in millimeters system. Let's say I'm gonna go with 200 millimeters for the length and 100 millimeters for the height. To escape operation, just go to the just right click and select operation. For this operation, to complete this operation, just exit the sketch, and now we have our base plan operations. Here you can see we need to define some parameters. First of all, some of these parameters are these parameters are advanced parameters. We are going to go with simple features. Just select your appropriate dimension. This will be defining our length of our thickness of the sheet. Let's say I want a sheet of about 200 millimeter in width and 100 millimeter in height, and with a thickness of 2 millimeters. Just like basic extrude feature, it is asking for the direction. You can reverse this direction as you want. Then we have bending allowance. Bending allowance is a factor that depends on the material and varies from material to material. Uh, when we will be using bending operations, there will be a corner operation over there. For that operation, you need to define a K factor. Let's say we're gonna go with a default value of 0.5, and then we have auto relief. Auto relief is for the bending operation, and it will apply a corner treatment to the edges for the efficient bending operation. First of all, let's go with default values and hit OK. Now you can see we have sheet metal component operated operation over here, and then we have our very first operation, let's say I want edges of this plate to be extruded upward, and I can do this with a boss extrude feature. But if I do with box extrude feature, we will not have a definite sheet metal profile. To make it a sheet metal, just go to the edge flange feature and select appropriate edges. When you select an edge, you will see a preview over here. This preview is showing that what will be the edge of this feature and what will be the height of this operation. Just we have selected our edge, then it's asking what is the angle. Let's say I want an angle of 45 degrees. Now this flange, this edge is tilted at 45 degrees angle. Let's go with 90 degree angle. And then we have flange length. Flange length is being controlled by this operation over here. You can change it to whatever you want. Then if we look over this edge, you can see we have different flange positions. Flange positions are what you want to flange to be started from. Currently, it is set to start within the range of this plate. You can select other operation and try this on. I'm gonna go with a simple operation to maintain the thickness of this plate, to maintain the width of this plate. Then we can make custom bend allowances, custom relief features, and other stuff like that. Let's go with the default values and select OK. Now you can see we have created a simple plate and with the extruded edge on the side. Similarly, let's go to the flange operation again and select other edges. Let's say I want these edges to be exact length of this operation. Go to the blind option, and select up to vertex. For the vertex, you can select any vertex. I'm going to go with this vertex over here. To accept the operation, just right click and it will do the job for you. Now, if we look on the side, we have a poor edge treatment over here because these operations were not made in a single step. If we go to the isometric view, let's do the same for this operation over here. Edge flange, select the edge and extrude it up to this vertex. Similarly, you can see we have a poor edge treatment over here. To make it better, we can simply select this operation and hit suppress. Now in this step, we will extrude all the edges in a one step. For that operation, just go to the edge flange and select all 4 edges. You can give any dimension as you want. Let's say I'm going to go with this side, and then I want edge operation to be applied over here. Currently, it is set to an operation that is called shearing. It is called tearing. Like it will tear apart the edges of this part, and it will create an assembly for you. Currently, you can see we have an edge operation over here. Similarly, we can extrude other features, other edges. Like let's say I want to go with this edge and select appropriate length. If we go to the edge flange properties, we can see edit flange profile. Currently, it is extruding this edge over here. We can change this profile. We have another operation over here. As you can see, we have equal distance from each other from each operation. The main feature over here, the main use of this sheet metal operation is after completing your sketch, you can just unfold it. You can see a sheet metal or a complete profile of the operation. As you can see over here, we have a simple profile of sheet metal. Like if we feed this data to a laser cutting machine, it will cut appropriate dimension, and it will give us this profile over here. After cutting it into appropriate dimensions and bending it, we will have this profile over here. Similarly, this was the first operation. The second method of using this profile is by converting a simple box extruded feature, simple body, into a sheet metal. Let's visit that operation. Let's simply select a plane. This session is postponed for a couple of minutes, and we will join back together very soon. Sorry for the inconvenience, ladies and gentlemen. Let's start with our continuous session. I was explaining that there are two methods to start an operation of sheet metal. First operation is go to the sheet metal and use sheet metal operations. The second operation is by making a geometry and then converting that geometry into sheet metal. Let's visit that picture. First of all, I have opened a new file. By using your favorite tools, just draw your shape. Let's say I want to go with a simple rectangle tool and draw a simple profile of rectangle. If you want to convert a simple geometry into a sheet metal operation, you need to consider some points. For example, you need to define some appropriate thickness that thickness will be used for the sheet metal operation. Let's say I want a simple box of random dimension. Now, in operation, if you want to make it a box of hollow from the inside, you need to perform shell operation. What is a shell operation? A shell operation will apply some thickness to the boundaries and cut the rest of the part over here. Just select your appropriate thickness and select any face you want. Now, as you can see, we have converted this box, this simple geometry, into a hollow box. Now, I want this box to be in the shape of a simple sheet. So I can feed this sheet into a laser printer and it can cut into appropriate dimensions. For that purpose, I need to convert this box into a sheet metal operation. For that purpose, we have second operation over here, that is convert to sheet metal. Go to this feature. Now, it is asking for a fixed entity. This entity will be acted as a parent object, and other operation will be folded around that object. For this operation, select your appropriate phase. Let's say I'm going to go with this phase. Next is it is asking for the sheet thickness. We already know that our sheet thickness is 2 millimeter. Then we have bend edges. It is collect all bends, and then it's asking for the rip edge font. Then select the OK operation. To use this feature, we need to insert some bends and rip the edges. First, select the rip operation and select the edges that you want to be ripped apart. I'm gonna go with these 4 edges. And select OK. Now, as you can see, we have cut these edges with a small gap. Now, these edges are not continuous edges. Similarly, we need to insert some bends. Go to the insert bend operation and select the face that you want your faces to be bent apart. Let's go with this face and select OK. For the for other advanced features, we have other operation like what kind of rip you want. Let's say I want to go with, there are 3 operations: rectangular, tier, and unbound. We will visit all these features one by one. Let's go with default feature, that is rectangular feature. Hit OK, and it's saying auto relief cuts were made for one or more bends. Let's see where are these bends. Previously, we have these edges as straight edges. Now we have bend operation over here, and this is called corner treatment. Like if we want to cut this operation, if we want to bend this operation in the simple sheet metal profile, we will not know that where we want this bend to be operated. For that operation, Solidworks automatically creates bend relief on the parts. Let's see this part when it will be folded. Simply hit flatten feature, and it will unfold the operation for you. If we look from the top view and look on the edges, this is called rectangular corner treatment. This Solidworks has created Solidworks has cut a rectangle on the edges, to easy operation, to the easy bending operation. Let's visit other operations. What are the other parameters? Just go to the edit feature operation, and you can change other parameters as well. Go to the insert main feature, select your main face, and let's go with tier operation. Just hit OK. That it will be tier. If you go to the pattern operation, you can see over here, Solidworks has not performed any kind of operation over here. Now, currently it is said to be torn apart. Like if you want to bend these edges will be tear apart. Similarly, we can see other operation. Go to the insert bend operation and select main face. This time we will be going with this operation. This operation is just like corner treatment of rectangular faces, but it gives an extra relief for the bending operation. Let's see how it will look from the pattern view. You can see this operation is just like a rectangular corner treatment, but it is giving an extra edges for the bending operation. Other than that, we have other operations. We have visited this edge plan operation. That same feature is just like an operation that is defined to avoid sharpened edges. What it will do, it will make a cut and it will make the edge round. For this operation, just select the appropriate edge, and Solidworks will do the rest of the job for you. To explain other these features, let's go to the side view. As you can see, currently Solidworks is defining this scheme from maintaining the height of this object. If we want this scheme to start from this top point, we can select other features. This is simple theme to make the edge round. We have other features like closed profile and open profile and other features. Let's say I'm gonna go with this closed profile. We can assign this dimension. Let's say I'm gonna go with 5 millimeters only, and now currently this theme is 5 millimeters only. Just select OK. The best part of using Solidworks as a sheet metal operation for the sheet metal operation is that any features you add will be added to this flatten feature. You can visit flatten feature anytime, and this feature will be shown over here. If we see the flatten feature, we have these lines over here. These lines are showing where you want to be your band to be operated. We have other features. Let's visit log feature. For this operation, Solidworks is asking for a plane. Let's say I want this face and draw a simple rectangle. For this operation, you need just only a single line. Solidworks is asking for other features like what's your fixed face? I want this face to be fixed. And what is our log offset? Let's say I'm going to go with 15 millimeter log offset. These are the other operations like where you want your log to be started, and this is our log position. Let's select by default values. You can also define an angle for the log operation. To use this log feature, your sketch needs to be a single line and it is supposed to be not on the edges. You can select other features over here and select OK. What this log operation have done, this log operation has moved the space uh, on the inside with the appropriate dimension that you have put it out here. You can also visit other operations. These are some advanced features and you can visit on there. The next module we have is Weldment. For the illustration of Weldment feature, let's open a new and go to the Weldment operation. What is a Weldment feature? This is also a main feature for the fabrication purposes. So far, you have visited all the features you visited other than sheet metal operation were for the assembly operation, for the designing of a part and then assembling it together. Only sheet metal and weldment operation are for the actual fabrication purposes. For this operation, a very main and important thing is 3D sketches. A 3D sketch is an operation that use simple sketching operations, and the main difference is it don't need any plane for this operation. Let's say I want to build a table, and this table will be made up of rectangular or square pipes. For this operation, we can use weldment operation. Just simply go to the edit 3D sketch feature. You can see this feature over here. Also, you can see over this operation in the sketch tab. If you select the drop down arrow and select 3D sketch, here you have started the 3D sketch. As you can see, Solidworks has not asked to select any plane because 3D sketch is independent of any plane. Let's go with a simple profile. Simply select rectangle tool, and currently it is asking for a plane. As you can see, we have y-axis on the top side and x-axis on the right side. This is asking that this plane, this geometry that you are going to draw will be drawn on this side over here. Let's see how it will look like. To change the plane, just hit tab operation and it will change the planes for you. By hitting tab operation, currently we are in XZ plane. By hitting tab, you can see we have converted into XY plane and similarly in YZ plane. Currently, I'm going to go with simple center rectangle and XZ plane, and draw your main rectangle. This rectangle will be used as our reference object, and we will drawing other operation from this reference. Select all the operations, select all the lines, and hit construction geometry, because this is our reference geometry. Let's give it appropriate dimensions. For this operation, I would like to work in IPS system. Let's say I want this table to be about 5 feet long and 2 feet in the width. This is our main operation. This is our main sketch that will be used for this operation. Next, let's draw the other operation. Let's say I want to go with main features of legs. For this operation, just hit the corners and set and draw a line. These lines will be later used for the as a profile for our weldment feature. If we want these lines to be equal in length, just select all the lines and select equal length. Let's define our dimension for these lines. Let's say I want this table to be about 2 feet tall. Next, we want to draw a top of of this table. For this operation, just go to the rectangle tool and select. Currently, it is working in XY plane. I want it to be work on XZ plane. For that operation, just hit tab and it will do the job for you. This is our main sketch that will be used for the weldment operation. We have drawn our main sketch and just hit XZ sketch. Go to the weldment feature and select structural members. This structural member, this tab consists of main operation that main assemblies and main profiles that are used for the assembly features for in the industry standard. Let's say I'm gonna go with ANSI. And then we have, this is our dimension standard. We have selected ANSI for our dimension standard. You can select any dimension standard that you want. Next is it is asking what kind of profile you want. Let's say I want a tube scale. It will create a scale profile for us, and then it is asking for a size. Then it is asking for the lines that we want to be worked on. Let's say I want to go with this line. Currently, it is producing a preview for us. You can select any appropriate dimension profile you want, and then select OK. We want this profile to be move around all this geometry. For this operation, just select all other lengths, and Solidworks will create a preview for you. If we see this geometry from the top view, you can see we have an edge treatment over here that every edge will be sliced at 45 degrees angle, and it will be welded together later on. We have other operation for this edge treatment. Let's say currently it is set to first add n meter. We can select second operation, and what it will do, it will cut the second profile, and it will remain first length will be in the actual length. We have other operations. You can select any operation that you want. By selecting this operation, just hit OK. I'm facing this problem. I don't know why, but the size operation is not working over here. Normally, you can select any size you want and hit OK. Let's cancel this operation and redo this operation. You can similarly select other bars for the leg operation. Currently, it is showing a preview of I-beam. You can select any cross section you want. Let's say I want to go with tube rectangle. See, it's creating a tube for me, rectangular tube for me. If we select any size, and it will change accordingly. In the previous operation, we selected all the top faces and it created a preview for us. But currently, if we want to select other legs, we will need to define a new group for that operation. Just select new group and select other lens. Other than that, we have alignment operation. Alignment operation over here. Currently, it is aligning. Aligning with this line over here. If we want to align with this line, just select this line. And the Solidworks will align all the operation with this line over here. Normally, if you select this OK operation, it will do the job for you. But currently, my Solidworks is causing some problem, and it will not allowing me to select the size.
Thank you so much, Mr. Ammad Ejaz. So here is an announcement for you all that sheet weldments has been covered, and the rest will be the date for rest session will be announced later. Now we'll be having a Q&A session. If you have any question, please raise your hand or ask in WhatsApp group. If you have any query regarding today's session, you can share your question in WhatsApp group and we will be answering it later. Well, ladies and gentlemen, today's session ends up here, and I would like to thank you all for being with us this afternoon and spending your precious time with us. The next module on visualization will be covered by Muhammad Al-Mujtaba on 4th March 2023. Have a blissful day, take care, and Allah Hafiz.